it works. Okay. Hi everyone. Thank you all for coming. Thank you for surviving after the first day. I will not gonna take a lot of time, so it's probably will be a pretty short talk. So I'm gonna talk about Fluence and what we are doing there. So I'm gonna briefly talk about three things about what we have today in the web, how it works, and what's the problem with that, the notion of decentralized web, and how Fluence helps decentralized web. Two words about us. We are working on Fluence, which is open source, decentralized, permissionless cloud computing platform. We are Fluence Labs. We are pretty tiny team of engineers. We're working on the project for a couple of years already. We have the first version launched, the first dev network. We call it dev network launched, and we're probably launching the officially next year. So speaking about today's web, it's there are a lot of concerns about how web works today, but the general thing is it's based on server-centric model, like a client-server application architecture, where you always have a central server which manages all the clients and stores all the users' data, performs most of business logic, and so on. So if and it is kind of in many cases it's highly inefficient architecture because if anything happens with the server, it goes down, it got hacked, it goes out of control, then anything just doesn't work. Usually, if you're talking about HTTP, also all the requests are not signed, so there could be man in the middle. You can temper requests, and it's not really great. Also, this architecture is perfect for corrupt governments, for censorship, for any kind of controlling and turning off service that somebody don't like. And also, it obviously doesn't work offline, just because you always most of your applications you're using on your iPhone, on a smartphone, in a browser, they just connect it to the cloud, and you will stop getting any functionality if you disconnect. And so here is where we are today. So previously we had a smaller amount of devices. Now we have more and more devices connected to internet, millions new sensors, wearables, smart things gonna be connected, and it just the growth just accelerating. If you think about future, so future is bright. We're gonna have drones, we're gonna have autonomous cars, we're gonna have machine learning, VR, smart wearables, and we're gonna have much more data that should be that will be generated and should be somehow processed and should be somehow used in the applications. And if it's all built on an old way of building an application that we are sending everything in the cloud, it obviously doesn't work. So yeah, the data amounts are growing. That's pretty obvious. They're growing very fast, significantly. And this is interesting picture. So from 2005 to 2014, the amount of bandwidth, the amount of traffic that goes between continents, increases 45 times, and now it's even more. And if we keep increasing the traffic we're sending over central channels, we will not be able to serve all of the new devices and new data that comes comes connected to the internet. Yeah, and again, so more and more devices connected, and this is also interesting thing is that this is private, fully private Google network of Google cloud infrastructure and Google cables under oceans, and they have to build all of this just to be able to serve continuously increasing amounts of data and like new users and so on. And think about that the thing is like the whole of this world infrastructure controlled just by one company. It controlled just by like administrators. It controlled like logically, it controlled administratively, it controlled like also by one country basically, like Google is kind of US based company. So anything happening like on technical level, anything happening on like a governmental level or like inside company, and we have problems like a lot of stuff will stop working, will be filtered, whatever. So they have a lot of control. And also think about the hacker attacks, like the cost of like the damage that can be, that hackers can bring becomes higher and higher just because we have all of this huge infrastructure in the hands of like small amount of people. And also like at the last World Economic Forum, I think it was reported that taking down a single provider, like cloud provider today, would bring damage from 50 billion to 120 billion just because like everybody is connected to cloud. And this is kind of numbers comparable to hurricanes. So like after hurricanes, we have very similar damage. So it's pretty impressive. Also, like obviously, you know, this all of these concerns about data ownership, data privacy, data sovereignty. If you go now to any media site, you will see, and you will if you have AdBlock or Brave browser installed, you will see how much data like different services trying to extract from your clicks and visits to be able to serve you advertising. And this is kind of silent model of the data extraction. Like it is what we all silently agree that like we are using these services for free, then we're giving out our data. But obviously it's not gonna scale infinitely because like people start concerning a lot about that you can like that advertising companies can manipulate their behavior, can manipulate their opinion because they know a lot about them. They know everything. You can like basically track any person with direct data or kind of indirectly. And the same thing is like all of the social media or content platform that we're using right now, they are like keep everything in single database, like they own this database, so you basically, it's not your content that you created, it's their content that you created, and they own it. If they want to take it from you, they can do it legally and technically. And this is also the issue. So they obviously use this to also monetize this content by advertising, to train machine learning models and this kind of stuff. And like another thing is about censorship. This is the photo from Hong Kong protests right now. And a lot of stuff happening in this space. In Russia, we had a very interesting story about Russian government trying to block Telegram for like significant amount of time, and they basically blocked millions of IP addresses that Telegram used or not. Like they blocked zones of IP addresses, and it led to the fact that in Russia, like in some days, just half of internet didn't work. Like half of Amazon AWS IP addresses were blocked, half of like Microsoft Azure cloud IP addresses were blocked, and it was like a chaos. It was like nothing worked. And it's so stupid, it happened because founders of Telegram, they refused to give Russian API keys, like encryption keys from their messenger. And like the government has this power because of centralization of the infrastructure and centralization of like how application works, like applications works on the internet. Also Hong Kong. Hong Kong, I don't know now, is internet, was it shut down or not, but like government was saying a lot about that because they have this power, they have this ability. And FireChat example, FireChat is a mesh peer-to-peer messaging application which works without central connection to internet. It works like between devices using Bluetooth and Wi-Fi and so on. And people continue using this during the internet shutdowns, during massive protests, and it helps coordinate and communicate activity between people during such periods. And so again, another like things that internet, like even besides censorship stuff, internet is not really stable in many locations in the world. Think about natural disasters when you cannot basically reach your relatives or friends. Internet just shuts down. You cannot call. You cannot text message. Think about subways, tunnels. Like we are used to be like to stay connected everywhere, but like it's really frustrating when you got disconnected. Even like you in the city, but you in tunnel, so nothing works. And think about, for example, that like on conferences, it happens pretty often that internet just goes down because too many people in one location. So, and imagine that just we want to exchange some files or we want with you collaborate on some document. And if we don't have the connection to the cloud, we all have like Google Docs installed, but we cannot connect to each other. This is like kind of really stupid. Like 90% of software that we have just doesn't work without connection to the internet. And this is what happens in the cloud space. So we started maybe 10, like 20 years ago from building applications with central servers, which we rented from data centers or installed at our homes. Like it was dedicated servers, so you take the server, you install the operating system, you install web server, and now you can serve some database or application. Then infrastructure started a little bit like abstracting out with the virtualization. And here clouds became really useful. So they allowed you to basically scale your application. If you have like a really growth in demand in your user base, you can scale easily. You don't need to buy new hardware and to coordinate different servers and so on. So virtualization helped a lot. Containerization was like the next step. It just helped to manage many applications across different infrastructure, data centers, and cloud providers. And serverless is the latest step that we have. It completely abstracts out the infrastructure. Cloud service provides you just a way to execute some random code, and it will be executed on a random node, but with the guarantee that it will be done fast, and you will be able to scale like immediately to millions of requests if you want. And now we have a little bit better things to organize web. And yeah, like this is all about peer-to-peer protocols, open protocols, more secure things, and so on. And here's an example. Oh yeah, like it's peer-to-peer, so you basically connect everybody, like all the devices together. There are no central servers, but there can be different roles on the network. So obviously, on your device, you cannot compute any like complex code. So there are maybe like based on this concept, there are maybe like cloud servers. There are maybe like a CDN, fog nodes who perform computations close to devices, and there are edge devices like browsers, smartphones, cars, and so on that process data and that generate data and send it for processing to fog nodes, and like all of this connected, and all of this theoretically should work in without stable internet connection. And there are like decentralized file systems who are make basically the ability for us to have, again, like static web. We will be able to have web, like web pages, but on the peer-to-peer network. And it works fine, like the IPFS, Swarm, RWeave. It works fine, but it works only for static data for files. And also, like, think about when I think about like decentralized file systems, the code is actually data as well, and the code is kind of file as well. So these systems are very useful to distribute and deliver data, all kinds of data and code between peers on the network without requiring any centralized provider to coordinate them. But they cannot execute you the code. And this step forward is how can we enable the rich, dynamic, decentralized web and decentralized applications. And here is Fluence. Fluence is a peer-to-peer, cross-platform computing network, which is meant to be faster, scalable than existing cloud solutions because they are limited by infrastructure. It meant to work offline because it's based on peer-to-peer network. And this is very easy how it works. It's basically the Kademlia DHT that organizes the network and peers together. This is WebAssembly execution engine where the code is run, and WebAssembly allows you to run the same piece of code on any platform, on any device, and WebAssembly is basically the new JVM. So you can run it on a smartphone, you can run it in a browser, you can run it on a server, you can send container with the code everywhere and run it in sandboxed environment anywhere. And it's Fluence based on decentralized file systems, which allow to manage the state of applications. So the data between peers can be delivered by such systems. And if you think of Fluence versus existing clouds, Fluence allows to have the best way to run application is to run to have the code and to have the data on the same machine. It gives you the biggest performance. And if you think of serverless architectures, they usually have the data and computations decoupled. For example, data sits in Amazon S3 or Amazon RDS, and computation is run on some random node on Amazon network. And in order to perform computation on top of data, they need to transfer data between their services and between different nodes. Fluence allows, because it's open network, it allows different kind of code to be composable together. You can say, okay, I'm doing the application. It depends on that API and that piece of code that's available publicly, and I just reuse that. I just plug into that code, and the network will find a way to compose your piece of codes together and run it on the machine that will give the best latency and the best performance. And just quick example. So basically, imagine that we have the application on our smartphone, which makes the machine learning generated filters for picture. We had Prisma, a couple of very popular application a couple of years ago, and the way how it worked, they basically, when you wanted to apply filter to your picture, they uploaded picture to the cloud, they ran machine learning, they applied machine learning model to this picture on the cloud because it's pretty heavy computation, and they send it back to you, to your device, because it was really hard to execute this on a smartphone. So if we do it a little bit differently, if we do it on top of IPFS and Fluence, we would use IPFS to distribute picture on a network, and we will use Fluence to execute a machine learning model on top. And so we have two ways, basically, what we can do. We can upload picture to some node that say, OK, I will execute this code the most efficient way. and it will get the machine learning model itself and some like any additional data via IPFS transport. Or we can do differently. We can download the model to device and execute on device. But like for some cases, like in this example, executed on device probably not the best case. It is better to upload to some like closest node and execute. But for some cases it works. So it gives the flexibility to executing code on top of data on any peer in the network. And on top of this, we create a computing market. So basically, there are different providers that can say, OK, like I'm renting out my computing power, my hardware to the network, and you can execute your code on my network. We use gas notion to account computing. So basically, CPU cycles as and memory as you have in Ethereum for accounting. And like 2 words about costs. So because it's an open market, it's permissionless market, any hardware can participate, not just server hardware, but commodity hardware, which is much more cost efficient but less reliable. However, if you connect the commodity hardware via the open protocol, we have real chances to make it much cheaper. And the second thing is, if you think of the ecosystem of open services and open APIs and open functions available on the permissionless network, they all can be reusable, and they all basically are free. So there are no additional charges for cloud services. On Amazon, now if you want to rent managed database or any kind of cloud service, you would pay a huge margin. You would pay twice or more than renting the same hardware just on Amazon EC2. Just like for servers, they charge more than for just hardware. So yeah, like this computing market allows us to organize the network in a way that the load balancing between peers happens on the upfront incentive basis. So nodes on the network are incentivized to cache the data and the code in advance to be able to be ready to serve requests anytime to give the client the best latency. And this way they will be able to earn money. It obviously allows us to scale between different cloud providers. And the interesting thing is basically this computing layer on top of decentralized file systems creates the additional incentives for nodes to store data. It creates additional data availability without having Filecoin, without having like other incentivized model for storage itself. And very short, so this is again the example of if I have, if I need to execute code that uses like another code and another modules and other functions, they can be found on the network and executed, either like by different nodes, or they can be just put together on the single node and executed together, and it will be like the best way to do this. And if you have such an open networks or such an open services, there are really cool dynamics. So we can have built-in incentives for people who create open services that are available for other applications, because they can earn the part of gas that their services consumed being installed and being used by other applications. So it creates basically the monetization model for open source developers to create open services, to deploy them to the network, and to monetize their open source contribution. And yeah, we have the first version of network up and running. It's available at dash.fluence.network. There's our white paper and our payment and token economics. Also, pretty interesting. Check it out. And there is just an example of first ecosystem that we create of open services that we create around this protocol. We have a couple of databases ported to a network. We have a couple of implementations of cloud functions. We have some cryptography libraries. Most of that built by community already. and we're looking forward to making this infrastructure or making this ecosystem bigger and to grow. Yeah, and that's it. Thank you. Here is our contacts. Feel free to reach me by email. Feel free to follow us on Twitter or join our community, ask any questions. Thank you.